our task. Find the limit if it exists. We'll state positive or negative infinity as we should when it doesn't exist, and we'll show work of course. Here's our function. Oh, there it is again. Let's simplify. You know, we're trying to avoid a mess. We're trying to avoid just plugging in and calling it infinity over infinity, the indeterminate form. Well, if I want to factor the numerator, I'm going to take out the biggest power of x. I'm left with a 1 and 6 divided by whatever it is I took out. If I factor out x cubed, I'm left with 1 minus 1 over that thing. Okay, well, this is not so pretty, of course, as usual. Where do I have more x's? At the top. How many more? Psh, psh, I just have one more. Okay, well, let's rewrite that. And it still looks the same. But now that we've done some simplifying, we can go ahead and plug in infinity. If we divide 6, something pretty doggone small, by infinity, that approaches 0. And if we divide 1, something tiny, by something very large, that approaches 0. So what we're left with is x times 1 plus 0 all over 1 minus 0. What that really means is we're left with infinity times 1 divided by 1, which is just infinity. So this limit would be infinity. Now, what if we had been looking at the limit as x approaches negative infinity? Well, if we were to plug a negative infinity in the end, our y values would be approaching negative infinity. So we've considered what if we were looking from the left, or what if we were looking from the right? Done.